14th question is based on Taylor series, Maclaurin series more specifically. So let's just see what is given in the question. Um, so f of x is given here for the question, and x belongs to R. They've said that f k of a, basically the kth derivative of f evaluated at a. So this here is the representation for that basically. Okay, and they have asked us the value of f10 of 0. So basically the 10th, let me write this down. So f10 of 0 denotes 10th derivative of f evaluated at 0. Okay, so okay, now the given f of x is e power x minus e power minus x divided by 2, right? And we know that this is basically the function in terms of exponentials for sine hx, the hyperbolic sine function, right? This is a basic direct formula. Okay, and we can also write this as, so there is a standard expansion for these hyperbolic functions, right? So similarly, similar to, sorry, how there is this equation in terms of the exponentials, there is also a standard expansion, the exponential expansion or power series basically for these hyperbolic functions. So for sine hx, it is basically x plus x cubed divided by 3 factorial plus x power 5 divided by 5 factorial and so on. Okay, and basically it's in the odd powers of x. It doesn't contain any even powers, right? So this is the property of sine hx. Now we will go to Maclaurin series. So the Taylor theorem or Maclaurin's series, which is basically the Taylor series about or around x equals a equals 0, is given as f of x equals f of 0 plus f dash of 0 divided by 1 factorial times x plus f double dash of 0 divided by 2 factorial times x square and so on. Okay, so this is the Maclaurin series expansion. Now what we have to do for this question is compare the standard expansion of the sine hx or the given function with the Maclaurin series expansion. Okay, so let me write this down as a general formula. So this can be written as summation k equals 0 to infinity the kth derivative. I'm writing in terms of the question's notation. So the kth derivative about 0 divided by k factorial times x to the power k. Okay, so this is the Maclaurin series expansion. Now we will compare this, say, so I will write this is 1 and I will write this is 2, right? So now we compare 1 and 2. So basically what we want from the question, it's f, the 10th derivative of f about 0, right? We want f 10 of 0. Okay, so if you look at the comparison, basically uh, the let's go case by case, right? So let's say, when let's consider the third derivative, right? So f3 of 0, if we want to look at, and if we compare these two, so this will be f3 of 0 divided by 3 factorial x cubed. And what is the corresponding term in the expansion of sin hx? That is this, right? So that is equals x cubed divided by 3 factorial, which implies f, the third derivative about 0 is 1, because these cancel out, right? But if you see here, if you do the same thing for even derivatives, basically when k is even, as in the case of 10 as well, you won't find the corresponding values here, right? Because in this expansion, the even powers of x are not present, right? So if we want so I'll write this as an example. Now here I'll say, for the 10th derivative about 0, you can say that through the comparison, f10 0 divided by 10 factorial x power 10 equals, since there is no power of 10th term in this series, we can say it as 0 times x power 10, right? Because at the end that is 0 as well, and that is valid. And now what happens? This implies the 10th derivative about or around 0 is equal to 0. So that's what we get. And hence the answer to this question is A, 0. So I hope you understood especially why we are comparing the expansion of the sin hx with the Taylor series, right? So basically, or the Maclaurin series. So basically the Maclaurin series directly tells us the derivatives at 0. Yeah. So what we are doing essentially is we are matching the coefficients of x bar k, and since the term here is missing in that series, the corresponding derivative will be 0. So that's what we are concluding at the end. I hope this is clear, and yeah, thank you.